6.5 goes over division of polynomials. When we are dividing these, we're just factoring if we can, and then simplifying from there. A lot of times it's much easier with these to put them in fractions so you can see exactly what you are simplifying. So with example 1a, we are given negative 12x to the 5th power divided by 2x to the 3rd power. Again, write it as a fraction. This gives us negative 12x to the 5th power over 2x to the 3rd power. Remember your rules for exponents as well. If you are dividing, you are subtracting those powers and keeping the power that's positive or bigger, wherever the power is bigger is where the variable will stay. So if you look at this, the 12 and the 2 are both divisible by 2. The negative 12 becomes a negative 6. The 2 becomes a 1. Your x to the 5th power over x cubed, that x cubed goes up top, and we subtract the 2. So this is just leaving us with negative 6x squared. For example B, we have negative 20x to the 6th power plus 8x to the 4th power minus 4x squared divided by 4x squared. Now you could do this one of two ways. You could start by putting it into a fraction, or you can factor each part, then put it into a fraction. It's totally up to you. If it's up to me, or if I'm doing it, I would want to factor first before I put into a fraction, just because I feel that's easier for myself. So if I look at each of these separately, that negative 20x to the 6th power plus 8x to the 4th power minus 4x squared is all divisible by negative 4x squared. So this is going to give us negative 4x squared times 5x to the 4th power minus 2x squared plus 1. This is all being divided by the 4x squared. From here, if you can factor that 5x to the 4th power minus 2x squared plus 1, you can do that as well. The 5 times 1 is just 5. You don't have any factors that add up to be negative 2, so we leave it the way we have it, and we write it as a fraction. So it's going to give us negative 4x squared times 5x to the 4th power minus 2x squared plus 1 all over 4x squared. From here, we are going to simplify that negative 4x squared and that positive 4x squared. They both cancel out, but it stays negative. So this is just going to be the opposite of 5x to the 4th power minus 2x squared plus 1. For our next example, it is already in fraction form for us. With this, we can write it as long division and use long division for it as well, which is what we are going to do. When you give the remainder of these, they stay underneath, or they stay over, the remainder stays over your denominator. So if we look at example A, we have 6x minus 1 over 2x. It's divided by 2x. So that 2x is going on the outside of our division house. That 6x minus 1 goes on the inside. So this is just another way of doing this. For the 2x times what? You want to ask yourself, times what? What am I multiplying the 2x by in order to get the 6x? Well, if I multiply it by 3, I have 6x. So I'm going to take that, and now I'm going to subtract. Use your rules for long division. The 6x minus 6x gives us 0. We bring down that negative 1. So then we have 3 and negative 1 over 2x. Now with this, that negative 1 is going to stay there, and we're going to add these two. So that way we have a whole number plus that remainder. That remainder is that negative 1, and we keep it over the 2x. For example B, it's probably going to be the easiest one that we do this entire lesson. you have x cubed minus 4x squared plus 5x minus 3, all divided by 2x squared. Now, if we do this, actually it may not be the easiest one because there is a way of doing this. So we have the 2x squared on the outside. On the inside we have x cubed minus 4x squared plus 5x minus 3. You want to ask yourself, 2x squared times what is going to give me x cubed? How am I going to get rid of that 2x squared and turn it into, or a 2 and turn it into a 1? If we multiply the 2 by 1/2, it gives us 1. If we also multiply the x squared by x, it gives us x cubed. So 1/2 times 2 is just 1. X times x squared is x cubed. From here, we are going to subtract these two. We get 0, they cancel out. We bring down that negative 4x squared. From here, the 2x squared times what is negative 4x squared? Well, if we multiply it by negative 2, we get negative 4x squared. If we then subtract these two, it turns into addition, and we add the opposite. So this cancels out. We bring down that 5x. You can't do anything to the 2x squared to make it 5x. You bring down the negative 3. Can't do anything to the 2x squared to make it the 5x minus 3. So that is your remainder. From here, you have 1/2 x minus 2. What's your remainder? Add it to that and keep it over what you divided by. So 5x minus 3 divided by 2x squared. For our next part of this lesson, we are going to be dividing by a binomial. So in example 3, we're told to find the quotient and the remainder of x squared plus 3x minus 9 divided by x minus 2. So that x minus 2 is going to go on the outside of our division house. The x squared plus 3x minus 9 goes on the inside. So from here, you want to ask yourself, the x in the x minus 2, what am I going to multiply that by in order to get it to be x squared? We multiply it by x. So then I multiply that x by x and by negative 2. So this is going to give us x squared minus 2x. From there, we subtract and we add the opposite. So it becomes addition, add the opposite. The x squared becomes negative. The negative 2x becomes positive 2x. So from here, combine your like terms. X squared minus x squared minus x squared is 0. They cancel out. 3x plus 2x is 5x. And then we drop down that negative 9. We're going to continue to do the same exact thing. So ask yourself, x times what gives us 5x? If we multiply it by 5, we get the 5x. And 5 times negative 2 is negative 10. We are going to subtract these two binomials or add the opposites. So this 5x cancels out. Negative 9 plus 10 is 1. So this is giving us a final answer of x plus 5 plus your remainder of 1 over what you divided by, x minus 2. For example 4, we're dividing the 3x to the 4th power minus 2 minus 5x divided by x squared minus 3x. Now, we're going to do this a different way. When you are dividing a trinomial or a polynomial by a binomial, trinomial, polynomial, whatever, you have to represent every single power from the highest to the lowest. So with this 3x to the 4th power minus 2 minus 5x, rewrite it to begin with in standard form. So that gives you 3x to the 4th power minus 5x minus 2. You are missing the power of 3. You are also missing the power of 2 here because your highest power is 4 and your lowest is 0, which is what's on that 2. So we are going to rewrite this once again, representing all of those powers that are missing. So that 3x to the 4th power gets dropped down. From there, you should have an x cubed. You don't have an x cubed, so just add 0x cubed. You should also have an x squared, which you don't. So add 0x squared. From there, you have an x on that negative 5x, and you have a 0 on that negative 2. Your x squared minus 3x is fine. You don't need to do anything with that. If you want to add in a 0 and put plus 0, you can do that. There's no problem with it. So when we go to write this, we're going to have the x squared minus 3x divided by 3x to the 4th power plus 0x cubed plus 0x squared minus 5x minus 2. Start from the beginning. Ask yourself, x squared times what is 3x to the 4th power? Well, that's 3x squared. So I'm going to multiply the 3x squared by the x squared and the negative 3x. It's going to give us 3x to the 4th power minus 9x cubed. From here, I'm going to subtract, which just means to add the opposites. So the 3x to the 4th power becomes negative, that 9x cubed becomes positive. Those 3x to the 4th powers cancel out. 0x cubed plus 9x cubed is 9x cubed. And then we drop down the 0x squared. So now you're asking yourself, the x squared times what is 3x cubed? Or sorry, 9x cubed. If we multiply it by a positive 9x, we're going to get the 9x cubed. And then we multiply the 9x by the negative 3x, and we get negative 27x squared. From here, we subtract, which means we add the opposite, so that 9x cubed becomes negative, the 27x squared becomes positive. So now you have nothing from your 9x cubes and 27x squared. We bring down that 5x, so minus 5x, and then we start all over again. X squared times what is 27x squared? Well, if we multiply it by a positive 27, we're going to get the 27x squared, and 27 times negative 3x gives us a negative 81x. We are going to subtract these, which means we add the opposites. So those 27x squareds cancel out. Negative 5x plus 81x gives us 76x. And then we drop down that 2. You cannot turn x squared into 76x, so your remainder from this is the x squared minus 2. So your final answer for this whole thing is going to be 3x squared plus 9x plus 27 plus your remainder of 76x minus 2 all over what you divided by, which is x squared minus 3x. For example 5, we are just dividing, and we are using long division with this. So example A, we have 3x over x minus 6. So again, we're just going to use long division. That x minus 6 is going to go on the outside. The 3x goes on the inside. If you want to do 3x plus 0, that would probably be best. So that way every power is represented. From here, you want to ask yourself, x times what is 3x? Well, if we multiply it by 3, we get the 3x. We multiply the 3 by the negative 6, we get negative 18. And then we subtract these or add the opposite. So this gives us an 18 left over. The x does not go into 18 at all. You cannot multiply it by anything in order to get 18. So we have this solution of 3 plus 18 over x minus 6. For B, or for example B, you have to make sure that you have every single power that's represented. The highest power there is the 3. So ask yourself, do I have x squared? You don't, so you have to represent it. The first thing I would do is to rewrite this as 4x cubed. You don't have that x squared, so you're going to add 0x squared to it. Then you have that minus x and minus 9. From there, in your denominator, you have that 2x minus 3. You're good there. That will go on the outside. And then the 4x cubed plus 0x squared minus x minus 9 goes on the inside. Ask yourself, 2x times what is 4x cubed? If we multiply it by 2x squared, we get 4x cubed. And 2x squared times negative 3 is negative 6x squared. We are going to subtract these, or add the opposite. The 4x cubes cancel out. 0x squared plus 6x squared is 6x squared. And we bring down that negative x. From here, 2x times what is 6x squared? If we multiply the 2 by 3 and then x, it gives us 6x squared. We also multiply the 3x by negative 3 to give us negative 9x. We are going to subtract these, or add the opposites. So this gives us a negative x plus 9x is 8x. And then we bring down that negative 9. We want to ask ourselves, 2x times what is 8x? It gives us 4. So 4 times 2x is 8x. 4 times negative 3 is negative 12. Subtract these, or add the opposite. This cancels out the 8x's. Negative 9 plus 12 gives us a positive 3. That 3 is our remainder. So our answer for this one is 2x squared plus 3x plus 4 plus 3 over what we divided by, which is the 2x minus 3. For our next part, we are going to be working with synthetic division. When you're working with synthetic division, it's literally a shorter way to use long division. Or instead of using long division, you can do a shorter version of it and use the synthetic division. When you use synthetic division, you are going to take every single coefficient from the highest power to the lowest power, including the constant, and put those down. Whatever you are dividing by, you're going to set it equal to 0, and you're going to solve for x. That number is going to go on the outside of your synthetic division. From there, you're going to drop down the first number. So if you see here, we're going to drop down the first number. From there, we multiply that number by the number that's on the outside and put it underneath your next coefficient that you have there. So here, let's do this from the very beginning. If we have x cubed minus 5x squared plus 4x minus 3, those coefficients and the constant are 1, negative 5, 4, and negative 3. That's where we're getting the 1, negative 5, 4, and 3 on the top numbers of that synthetic division. From there, you're dividing it by x minus 2. So if we take that x minus 2, set it equal to 0, and solve for x, we get that x is equal to 2. That 2 is what's going on the outside of that synthetic division. From there, like we just said, you're going to drop down the first number, which is 1. You're going to multiply the 1 by 2, put it underneath that negative 5. From there, you're going to add. Negative 5 plus 2 is negative 3. From there, take the negative 3, multiply it by the 2, put it underneath your next coefficient of that 4. Then combine those. That 6 is negative, so just subtract them. 4 minus 6, negative 2. Take the negative 2, multiply it by the 2. That gives you a negative 4. Put it underneath the negative 3 and combine those. When you have these, if you are left with a number, that number is your remainder. So that is what goes over that term or that binomial that you are dividing by. So from here, you have your constant, your x squared. The whole idea with these, you could either work this one of two ways. I work it backwards. So I say this number that's the first number to the right is my remainder. Then the number next to that is my constant. Then I have x and x squared. So I don't have to figure out from the very beginning what I'm starting with. Normally, when you do start from the beginning, going from left to right, you have to look at the highest power that you're starting with that polynomial that you got those terms on the inside of your synthetic division, and you want to subtract 1 from the highest power. That gives you your first power from left to right with these numbers. I don't care for doing it that way, because to me, I just find it much easier to go from right to left, knowing that my number that's on my right is my remainder, then my constant to the left of that, then my x squared to the left of that. If I have any other numbers, obviously my powers continue to go up as I move to the left. Okay. If we look at example 6, we're using synthetic division to divide the 2x to the 4th power minus 5x squared plus 6x minus 9 by x plus 2. There's a few things that you have to do with this. Yes, you're going to take that x plus 2 and set it equal to 0 to see what the number is going to be on the outside of your synthetic division. However, if you look at the polynomial that's given to you, that 2x to the 4th power minus 5x squared plus 6x minus 9, it does not represent every single power from 4 to 0. So you have to rewrite it with every single power represented, just like we did with long division. So that 2x to the 4th power, that's your first term. Keep it your first term. Do we have an x cubed in there? No, we do not. So then you have 0, x cubed. Then you have x squared, which is that negative 5x squared. Then x, which is that 6x. Then your constant, which is that 9, or that negative 9. Take the binomial that you're dividing by, set it equal to 0, and solve for x. Move the 2 over by subtracting it from each side. You get that x is equal to negative 2. So that negative 2 is going to go on the outside of your synthetic division. From here, you want the coefficients and constant from that 2x to the 4th power plus 0x cubed minus 5x squared plus 6x minus 9 to go to the right of that negative 2. So I'm going to have a 2, a 0, a negative 5, the 6, and a negative 9. So you see here that the signs with the numbers, the signs in front of the numbers, stay with the numbers. The first number that you see to the right of that box that negative 2 is in, it drops down. From here, you're going to multiply that number with the number in the box. So 2 times negative 2 is negative 4. It goes underneath your next coefficient, which is that 0. Combine the 0 with the negative 4. 0 minus 4 is negative 4. From here, multiply the negative 4 with the negative 2. Negative 4 times negative 2 is positive 8. Put it under the negative 5 and add it with the negative 5. 8 minus 5 gives us 3. Take the 3, multiply it with the number in the box, which is the negative 2. We get negative 6. Combine the 6 with the negative 6 that you just put the negative 6 under, and you get 0. Then multiply the 0 by the number in the box, which is 0, and put it underneath the negative 9 and combine those terms. Negative 9 plus 0 gives us negative 9. So like we said before this, we're going to start from the right and move left. The number on the right is your remainder if you have anything other than 0. Then you would have your constant, your x, the x squared, and x cubed. If you want to check to make sure this is right, the first number from the left to the right should be 1 less on the power that you started with. The power that you started with was 4. 1 less than that is 3. That 2 is going to get an x cubed. We're good. So now put this all together. This is going to give you 2x cubed minus 4x squared plus 3x plus 0, which we don't have to write, plus our remainder, which is negative 9, over the binomial that we were dividing by, which is x plus 2. From here, you're done. For our next example, We're asked, is x minus 1 a factor of 6x cubed minus 5x squared minus 4x plus 3? If it's asking you whether or not a binomial is a factor or not, if you use synthetic division and you get a remainder of 0, it's a factor. If you do not get a remainder of 0, it is not a factor. So we're going to do the same exact thing that we did in the question before this, except this time we're checking to see if that x minus 1 is a factor by seeing if we have a remainder of 0. If we look here, that x minus 1, we said equal to 0. We move the 1 over. We get that x is equal to 1. The polynomial that we are given, that we're dividing that x minus 1 by, has every single power from the highest, which is 3, down to the lowest, which is 0. So we're going to take the coefficients and the constant. It gives us 6, negative 5, negative 4, and 3. Those are the numbers that are going in our on the right-hand side of the box with our synthetic division. The 1 goes in the box. We have 6, negative 5, negative 4, and 3 to the right of it. We said we drop down that first term, which is 6. From there, multiply the 6 and the 1, put it under the negative 5, that's 6. The 6 is positive, so add these two numbers. Negative 5 plus 6 is 1. Take the 1, multiply it by the number in the box, which is 1. 1 times 1 is 1. Put it underneath your next number, which is negative 4. That 1 is positive. Add it with the negative 4. Negative 4 plus 1 is negative 3. From here, take the negative 3, multiply it by the number in the box, which is 1. Negative 3 times 1 is negative 3. Put that underneath your last coefficient or constant that you have there. 3 minus 3 gives us 0. Ask yourself, is our remainder 0? It is, so x is equal to 1. It works, which means that x minus 1 is a factor. For our last example, we're going to be using synthetic division to find if P of something is a solution, or what the solution is of P of whatever is given to us when given a polynomial. So example 8 tells us to use synthetic division to find P of 2 when P of x is equal to 4x cubed minus 5x squared plus 6x minus 7. This just means use 2, the number in P of 2, as the number in your box in synthetic division. Work out your synthetic division. Whatever your remainder is your answer. So, check your polynomial. You have x to the power of 3, x to the second power, x, and your constant. We're good. Our coefficients and constants here are 4, negative 5, positive 6, and negative 7. Those are the numbers that are going to go to the right of when we put this 2 in that box. This 4 drops down. 4 times 2 is 8. That's where it is. So 4 times 2 gives us the 8. We add that with the negative 5. That gives us 3. 3 times 2 is 6. Put it underneath the 6. Add them. We get 12. 12 times 2, 24. Add them. We get that 17. So your remainder is 17. P of 2 is 17.